Okay, so we said we need to be thinking about the formula y equals mx plus b. That's what we normally do when we graph equations of lines, right? Somebody remind me what the m stands for in this formula, Ryan? The slope. Good. Guys, what is the slope of all three of these lines? They actually all have the same slope. What is the slope of all of them? Anybody know? Like, that's like me asking you, what's the number in front of the x, right? Because remember, m stands for slope. So what number do you think is in front of the x in each of our equations if we don't see a number? Kale? Yes. Let's put that in there. So thinking about the slope doesn't really help us too much because they all have the same slope. So what we're going to have to do is look at the y-intercepts now. Okay, so when you think about the y-intercepts, this one actually has a y-intercept of 0 if we wanted to write the 0 in there. So that's going to match with the blue line, okay? So how many of you put A on that middle line there? Perfect. Now it's kind of like this line, if we start with the blue one, sometimes we call that the parent function because it goes right through 0, 0. This is like taking that and shifting it up 5 units. Like look for the one that has the y-intercept of 5, line B matches with that one. If we go back to the blue one and we shift it down 2 units, right? That would be like the y-intercept is -2. So that's kind of how you guys can look at this, as the blue line is kind of like your foundation, and if you shift it up or down, it's going to change the y-intercept. That's why we see that +5 or -2, okay? All right. Um, we're going to do a review question before we go on and start learning something new today. So do you guys remember how we learned before spring break that there's 3 ways to write the equation of a line? They're all over on the whiteboard right there. The first one we learned was called slope-intercept form, y equals mx plus b. The second formula that we learned is called point-slope formula. And then the third one that we learned just before spring break is called standard form. It looks like ax plus by equals c. Sometimes it depends on what we know. Like if we know the slope and the y-intercept of the equation, we usually use this formula, right? If we don't know the y-intercept, we could still use this formula, but we had to find the y-intercept if we don't know it, okay? Sometimes we use this formula instead. It just depends on what we know. So look at this review question. It says, write the equation of a line that goes through the point 4, -8 and has a slope of 1/4. So if that's the information that's given to us, which one of these formulas should we use? I want you to vote for me. Like hold up fingers for me. Which formula would we use? I'll leave the formulas over there on the whiteboard. We should be saying number 2 because guys, this point that it gives us, that's not the y-intercept. Like if I go graph that point 4, -1, 2, 3, 4, 5, 6, 7, 8, like that's down here somewhere. That's not on the y-axis, right? So we probably shouldn't use y equals mx plus b because we don't know b. We don't know the y-intercept. So it's going to make more sense to use point slope form. Guys, also, look, that's the reason it's called, look what we know, a point and the slope. Remember, that's why it's called point slope form. So let's see if we remember how to use this formula. We're going to fill numbers in here, here, and here. I'm going to call on 3 random people to tell me what numbers. So I'm going to write y minus, and then what number am I going to put right here? Emma, what do you think? What number would I put right here? Yes, good, because do you guys remember x comes first in an ordered pair, then y? So we need to put the y there, -8. What about right here? Let's see, Anna. Yep, because remember slope is m, so we're going to put 1/4. And then x minus, Lucas, what would I put there? Right here. Good. My x value, 4. Everybody, would you have, raise your hand if you think you would have remembered how to do that without me going over it. Good. Now, the only thing else that we have to do is minus and negative, we should change into a plus, okay? So remember, the form that we wrote it in right now is called point slope form. Look what part B says. It says convert your answer to standard form. Look over at the whiteboard at the choices. If you don't remember, standard form looks like this. So we want to change our answers so it looks like this when we're all done. This is what we practiced right before break. Does anybody remember what's the first thing we should do with this equation if we're trying to get it to look like this when we're all done? Graham? Perfect. So we're going to leave the y plus 8 alone, and we're going to distribute. You guys do the distribution on your own. I'm going to give you a minute to do that. So we're going to do the 1/4 times the x. And then for 1/4 times -4, you should have got -1. Did we get that? What next? It doesn't look like this yet. What else are we going to have to do with it, do you think? Anna? Perfect. We're going to have to subtract 8 on both sides because we want all our constants to be over on the right side together. 8 minus 8 is 0. We have to do -1 minus 8. That's going to be -9. What else? Like right now it's in slope intercept form. We're supposed to be getting it in standard form, right? So that means we're not done yet. Look at standard form. Remember how it has the x and the y on the left side of the equals. So that means this has got to get over there somehow. How would I get rid of it from the right side? Emma? Perfect. Good. We're going to subtract the 1/4 x. Because 1/4 minus 1/4 is 0. There'd be no more x's on that side. On this side, we just have to write y minus 1/4 x. We can't combine x's and y's. They're not like terms. Okay, we're almost done, but look at standard form. The x is supposed to come first. Right now, the y's first. So we should flip-flop these. But when you flip-flop it, be careful because the 1/4 is negative. It has to stay negative. And this is like a positive 1y. Okay, does anybody remember from before break why this is not the final answer? Ryan W? Perfect. We're not allowed to have, I like how Ryan was saying this is a, right? Because it's the number in front of x. It's not allowed to be negative, and it also isn't allowed to be a fraction. So what we had to do is we had to multiply this whole equation by something to do what we call clear the fractions. Does anybody know what number would be like the magic number to multiply by for this particular example that would clear the fractions? Any thoughts? Graham? Almost. If we do that, nothing would change. Anna? 2 is a good guess, but if we multiply by 2, there's still going to be fractions in it. Basically, go ahead, Ryan. Almost. We can just actually use 4. Like if you just look at your denominator, but then we're going to need to do -4 though because of the fact that we need this guy to turn positive. So listen, guys, you need to practice this on your own. You need to multiply every single part of this equation by -4 and write what you get for me when you're done. So -4 times -1/4 should have given you +1 x. -4 times 1 is -4 y. -4 times -9, +36. We don't have to have this one there. You can if you want, but we don't have to. Okay, that now is finally our final answer. So for the next section of chapter 4, we're going to be starting to learn about parallel and perpendicular lines. I'm going to pass out a chart to you that looks like this. So we have to remember that parallel lines never cross each other. They never intersect. So they look like this, okay? But what makes that happen in the coordinate plane? We've talked about this once already this year, but in case you forgot, they have to have the same slope. So if you actually look back at our warm-up, all of those lines were parallel because they all had the same slope, but they all had a different y-intercept, right? If they were to have the same slope and the same y-intercept, like let's say I added y equals x minus 2, what's going to happen if I graph that is it's just going to be right on top of the green line. It's not going to be parallel to it. It's going to be on top of it. That's called coincident. Jump down here real quick. If they have the same slope and the same y-intercept, they would be the exact same line, okay? So to be parallel, they have to have the same slope but different y-intercepts, okay? Do you guys remember, raise your hand if you remember the term perpendicular from middle school. Did you learn that word before? If you forgot what it means the lines are going to intersect or cross each other at a right angle. So if you want, you can put this little symbol on your picture. Remember that little symbol from middle school that means a right angle? So in order for lines to cross at a right angle like that, the slopes are going to have to be what we call opposite reciprocals. So I'm going to tell you what that means real quick. If the slope of one line is 2/7, like you might want to add this example to your margin here, the opposite reciprocal of that means -7/2, okay? Because reciprocal means you have to flip it over. Like, see how the 2 was on the top, the numerator, but now I put it in the bottom, the denominator, I flipped it. But also see how this one is positive and this one's negative. That's what we mean by opposite, okay? So if you had two lines that you had to graph and these were their slopes, then this would happen when we make the picture. They would cross each other at a right angle, okay? So if the slopes are not the same, so they wouldn't be parallel, and the slopes are not opposite reciprocals, so they're not perpendicular, then this is what's going to happen. They're going to cross, but it's not going to be at a right angle. Like, see how if I mark that angle, that looks like it's more than 90 degrees, okay? So if they're not the same and they're not opposite reciprocals, they're just going to still cross at some point, but they're not going to cross at a right angle, okay? So those are the 4 situations that can happen. We're going to look at a picture of several lines here. Anthony, guys, your head down again. What? I want you to make a prediction before we do any math. Like, your pencil should not be in your hand still. We're just listening. Do any of those lines look like they might be parallel to you? Any of them look like it? If you had to guess. Anna? Anna's guessing B and D, okay? So that's a good guess. How would we know for sure if they're parallel, though? What did it say on the chart that I just gave you, Ranveer? They would have to have the same slope, okay? So what we're going to do is we're going to have to find their slope. We're going to find the slope of all 4 of them, though, okay? So let's start with line A. Guys, what's the easiest way to find the slope of a line when you have a picture in front of you? Emma? Perfect. Rise over run. So let's do rise over run for line A. We're going down 1 and right 1, 2, 3. So the slope of line A is -1/3. Everybody good with that? That's just review. We should all know how to find slope. Anthony, where are your notes? We're taking notes on that paper. How about line B? Here's line B. What's the slope of that one? What's the rise over run? Up 2 and right 1. So we want to put 2/1. Normally we would just simplify that and write 2, right? Because 2 divided by 1 is just 2. I do want you to leave it as 2/1 for right now. You'll see why in a minute, okay? What about line C? What's the slope of that one? Rise over run. Anybody got it yet? Madeline? Perfect. We're going down 1 and right 2. So we want to put -1/2. And then lastly, we've got line D here. Let's count the rise over run together for that one. The rise is 1, 2, 3, 4, and over 2. So 4 divided by 2 is just 2. We should simplify. Now, I am going to have you write it as 2 over 1, though. You'll see why in a minute, okay? So let's go back. I asked you to guess if any of them looked parallel in the beginning. And Anna was thinking maybe B and D. So let's look at their slopes now. The slope of line B is 2 over 1, and so is D. So Anna was right. So we're going to say B is, guys, there's an abbreviation for parallel so that you don't have to write the word parallel. You can put that symbol if you want. B is parallel to D. And then we have to explain how we knew because, you know, in the beginning I asked you to guess. But now that we have to actually explain, we can't just say, well, we thought they looked like they were parallel. How do we know for sure? Because they have the same slope. Okay. Now we're going to go and look for if any are perpendicular. So perpendicular is a little bit harder to understand. Look back at your chart. To be perpendicular, the slopes have to be opposite reciprocals. Remember the example that I gave you, 2 over 7 and negative 7 over 2? So guys, this is why I had you leave 2 over 1 instead of writing it as 2. The reason I wanted you to leave it as 2 over 1 is because I want you to see that this number is what we call the opposite reciprocal of this. Because do you see how it's flipped over? It's 2 over 1, but then it's 1 over 2. See how it's flipped? But then see how they're also opposite. One of them's positive and one of them's negative. Like, guys, if this had been positive, that would be no good because they have to be opposite and reciprocal. But they are. So B and C, I'm going to highlight those for us. B and C, those are perpendicular, which it looks like it, right? Doesn't it look like that's a right angle? But the reason we know for sure that B is perpendicular, there's the abbreviation for perpendicular. If you don't want to write out the word, it's like an upside down T. How we know they're perpendicular is because the slopes are opposite reciprocals. So then also, though, these two are opposite reciprocals. So C and D, like the blue one and the purple one, are also perpendicular. That's also a right angle. So we have to also say that C and D are perpendicular for the same reason, because the slopes are opposite reciprocals. Okay, so there's more than one. There's only one pair that's parallel, the green and the purple. But then there's two pairs that are perpendicular. The green and the blue are, but then the purple and the blue are. Okay, questions so far at all? Keep listening and taking good notes, guys, because this lesson gets trickier and trickier as we go. We got to make sure we're paying attention. This is one of the harder things that we've done this year. So this is a multiple choice question, but there's going to be a lot of thought we have to put into it to figure out which one is the right answer. Which line would be parallel to the one shown here? So guys, we don't want to have to sit here and graph this one and then graph this one. We don't want to graph them all until we can see which one looks like it's parallel. Like the answer is going to look something like that, right? What we want to do is go back to your chart again. What makes lines parallel to each other? Anna? Yeah, I want you to start with that. We're going to have to also look at this, but I want you to start with the fact that they have to have the same slope. So that means the first thing we should do is figure out what the slope of this line is. So there's no dots this time, guys. So let's pick two nice points. Like you can make the dots yourself. What would be the slope, the rise over run of this line? Good. Up 2 and right 3. So is everybody good with that the slope of this line is 2 over 3? Are we good with that? Now, if we look through all of these choices, remember we're going to be looking for one that has the same slope, okay? So let's look through them carefully. We want to see which one has this, like we got to think about y equals mx plus b. The m has to be 2 over 3. So we can get rid of this choice because the slope of it is negative 2 over 3. We need it to be the same, 2 over 3. Okay, this one has a slope of 2 over 3, so maybe that's the right answer. This one has a slope of 2 over 3, so maybe that's the right answer. This one can't be the right answer because the slope is 3 over 2. We're looking for which one has the same slope. So I've narrowed it down to 2 choices. How would I now know which one of these is going to be parallel to my red line here? Madeline? Yes. So guys, I don't want to pick this one because watch what happens if I graph this line. It has a y-intercept of -2 and a slope of 2 over 3, which means it's the exact same line. Like it would be on top of it. That's called coincident. We don't want it to be coincident. We want it to be parallel. So it must be this one, but let's graph it to see. This has a y-intercept of +2, so go ahead and graph the y-intercept. And then the rise over run is the same though. So up 2 and right 3 means that the line is going to look like this. So those ones are parallel since they had the same slope but a different y-intercept. So we should choose C. Okay? Any questions on that at all? Okay, let's look at one more picture. And guys, then it's going to, again, it's going to get even harder without pictures. So make sure you're still paying good attention here. Which line, so it's another multiple choice one, would be perpendicular to the one shown? Guys, think ahead for a second. Perpendicular means it has to cross it at a right angle. So we're looking for something that maybe looks like that, for example, or maybe it's over here. But no matter what, it has to cross it at a right angle. So this time we don't want something that looks like that because that's parallel. We want it to be perpendicular this time, okay? So let's go back to our chart. What does it say? For lines to be perpendicular, what do we know about the slopes? Read it right off the chart to me. Opposite reciprocals, yes. So let's go find the slope of this line. Let's pick 2 nice points on the line. Somebody tell me what the rise over run of this line is going to be. Go ahead, Anna. Yep, we're going down 2, right? 1, 2, 3, 4, 5. So our slope of this line is -2 over 5. Don't, guys, be careful that you don't pick A. That has the same slope. So that would look like this. They would be parallel. The directions said look for one that's perpendicular, not parallel. This is why we have to read really carefully because on the last one we did parallel. So A would be the answer if it said parallel, but it says perpendicular this time. So we need to look closely at this number, and we said we need the number that's the opposite reciprocal of that. So which choice do you think it's going to be? B, C, or D? What do we think? Which one has a slope that's the opposite reciprocal? Yes, okay. We can't pick this one because it's just opposite. +2 over 5. It's not flipped over. Okay, we can't pick this one because even though it's flipped over 5 over 2 instead of 2, it's not opposite. Like this is negative and so is this. So this is the only one that works because the slope is flipped over, right? The 5 is on the top now, and it's opposite. Our original slope was negative and this one's positive. So that one should be perpendicular, but let's graph it to check. So let's graph a y-intercept of -2 and then a slope of +5 over 2. So up 1, 2, 3, 4, 5 and right 2. There's where our second point would go. I'm not very good at drawing a straight line, but if you're a little better at it than me, it should look like this is a right angle. It should look like they're perpendicular to each other. Okay, questions on that at all? Okay, again, guys, I like to teach things with pictures first because I feel like it makes it easier to understand it. But now we're going to move into ones that don't have a picture. So you have to kind of keep thinking about what we did on the last slide, though. Like in your mind, imagine if we graphed the line y equals 3x plus 1, it would have a y-intercept of 1, and then it would rise 3 and run 1, right? Like here's a rough sketch. We could picture it in our mind still, okay? So it says, what is the slope of a line parallel to this one? So imagine I graphed this line. What's the slope of this line, guys? 3, yep. So what would have to be the slope of a line parallel to it? Almost, we would just do still 3 because parallel lines have to have the same exact slope. So we don't want to make it opposite. We don't want to flip it. We don't want to do anything to it because they have to be the same. So that's our answer for that one. The question is worded a little bit differently. We don't, like on this one, our answer was a whole equation. This time it just says what's the slope. So if the slope of this one is 3, the slope of any other line parallel to it has to also be 3, okay? What's the slope of a line that's perpendicular to this one? So guys, first you have to ask yourself, what's the slope of this line? I'm going to call on random people because I feel like some of us are not paying attention. Elise? Yeah? I'm going to make you guys write it as 9/1. Please add that to your notes. Why would I make you do that? What makes lines perpendicular again? Read it to me off your chart. What makes lines perpendicular? Their slopes have to be, Lucas? We're reading it right off the chart. Perpendicular, the slopes have to be what? Opposite reciprocals. There's 2 parts to it, okay? So what would be the opposite reciprocal of 9/1, do we think? Elise? Yes, opposite means since 9/1 is positive, we're going to have to make this negative. Reciprocal means you have to flip it over, okay? So like last class, somebody thought the answer would just be -9. So they made it opposite, but they didn't flip it though, okay? Again, opposite reciprocal has 2 parts. You have to make it opposite, so negative instead of positive, but then you have to flip it. That's what reciprocal means, okay? Any questions on that one? Okay, guys, before we even read this question, Ranveer, why's your head down? Get it up. Before I even read this question, can somebody tell me what the slope of this line is? Why not? It's a trick question. You can't. Those of you who are saying no, why? Why can we not tell the slope? Anna? Yeah, it's not in slope intercept form. What form is it in right now? Yes, standard form. Standard form doesn't have an M in it. So if I asked you to find the slope right now, if you tell me 6, that's not the slope. That's not M. That's A, not M. We have to get it in slope intercept form first. Let's read the whole question now, though. What's the slope of a line that's parallel to this line? What makes lines parallel again? Read it to me off your chart. What makes lines parallel? Same slope, yes. We have to start to memorize this, guys. That's why I keep asking you. So we are going to have to know the slope of this line first, though. So we have to get y alone. How will I get y alone? What's the first thing I'm going to do here to try and get y alone? Jackson, what do you think? What I'm going to try to get y alone. What do you think's the first thing we would do? Take a guess. You have not even a guess. We've been doing this since like November. You don't even have a guess. Ryan? Mm-hmm. 6 minus 6 is 0. We have to just write 12 minus 6x, right? They're not like terms. 12 doesn't have an x on it. What now? Y is not alone yet. Ryan, what do you think? How do I get... I'm trying to get this y alone, so I got to get rid of the 8. How do I get rid of the 8? There's a dot, imaginary dot. So divide. 8 divided by 8 is 1. 12 divided by 8. Punch it in your calculator. Should give you a decimal. Somebody math frack it for me. Elise? Yeah, I want you to math frack it though. Yes, 3/2. Then we got negative 6 divided by 8. Again, punch it in your calculator, Anthony. After you punch it in, I want the fraction, not the decimal. So math frack it. Positive should be negative because we're doing negative 6 divided by positive 8. Don't lose your x. So what is the slope of this line, guys? Anna? Yeah, if you need to flip this around, like normally we put the x term first, right? So don't get confused and think that 3/2 is the slope. That's the y-intercept. So the slope of this line is negative 3/4. So what's going to have to be the slope of a line parallel to it? The same. Good, Gavin. So negative 3/4 is your answer. Okay. Questions on that one at all? Let's try a similar one. What's the slope of a line that's perpendicular to this line? Read me your chart. Again, what makes lines perpendicular to each other? The slopes have to be what? Anna? Opposite reciprocals. So it's all about the slope is the thing. So once again, like this is not in slope-intercept form. It's in standard form. If we want to know the slope, we're going to have to get it in slope-intercept form. Y equals mx plus b. So since we just did one together, you guys do this on your own. Get y by itself for me for us here. We would have to take away 8x on both sides. So 8 minus 8 is 0. Don't forget that negative 2y is left. 6 minus 8x we would write because they're not like terms. Remember, this is the goal because we have to know what is the slope, right? So divide, put your dot in there if you need to. Opposite of multiplication is division. 6 divided by negative 2 is negative 3. Don't forget that you're doing negative 8 divided by negative 2. That's positive 4x. You might want to write the positive 4x first because 4 is the slope, right? But so guys, again, one little word is going to change everything because if I asked you what's the slope, what is the slope of a line parallel, then we would just say 4. But it doesn't say parallel this time. It says perpendicular. That's why we're remembering again that the slopes have to be opposite reciprocals, which means we probably should make this look like a fraction. Because remember, reciprocal means you have to flip it and then you have to make it opposite. So if it was positive, now it's going to need to be negative. Okay, so if I were to graph this line in the coordinate plane, in order for any line to be perpendicular to it, this is going to have to be its slope, negative 1/4. Questions on that one at all? Okay, we got one more new question here, and then hopefully we'll have time for a spiral review. Determine which lines, if any, are parallel or perpendicular. So first off, this line's already in slope-intercept form. Remember, guys, the reason we need it in slope-intercept form is because this type of question, when it's talking about parallel and perpendicular, it's all about the slope, right? Look back at your chart one more time. Parallel lines have to have the same slope. Perpendicular, their slopes have to be like it's all about slope. okay? So we have to have them in slope-intercept form. This one already is, so we know that the slope of this one is 5. We maybe should write it as a fraction because, again, some of the questions like parallel and perpendicular, for perpendicular, we're going to be thinking about opposite reciprocals. This one doesn't have y alone yet. It's in standard form right now. We can't tell the slope when it's in standard form. Guys, I want you to put a 1 here, okay? So the first thing we need to do is get y alone. So we got to take away that 1x. Please make sure you're still taking good notes because you're going to have a problem just like this on Edulastic when you walk in here tomorrow. 1 minus 1 is 0. So all the x's are on this side now. Remember, we just write 2 minus 1x. They're not like terms. We can't put them together. Opposite of multiplication, we're going to divide everything by 5. Guys, you're going to get a bunch of decimals. 2 divided by 5 is a decimal. Just math bracket. Leave it as 2 over 5. Negative 1 divided by 5 is a decimal. Just math bracket. I would probably flip this around and put the negative 1 over 5x first, then the positive 2 over 5, because this is the number we care about, right? The most, anyway. We do care about the y-intercept, but we care about the slope the most. Okay? So far, let's just look what we have so far. If the slope of this is 5 over 1 and negative 1 over 5, what do you know about line A and B? Those are opposite reciprocals. Yeah. So line A and B are perpendicular to each other. So we can already say A is perpendicular to B. We know that already. Okay. But you have to be careful. We're not done with the question because maybe B is also perpendicular to C or something. Like we have to keep going. So this one also doesn't have Y by itself yet. So the first thing we need to do is get it by itself. So we would need to add 2x to both sides. Because negative 2 plus 2 is 0, right? So we have negative 10y equals, you can write 0 plus 2x if you want, but when you add 0 to something, nothing happens. So we could just leave it as 2x. Opposite of multiplication, we're going to divide by negative 10. So somebody let me know what you get when you do 2 divided by negative 10. Elise? Yep, because I don't want a decimal. I don't want negative 0.2. I want you to math bracket. So, guys, technically the y-intercept is 0 if you want to have the plus 0 there, okay? But remember, what we care about most is the slope. So the slope of this line is actually the same as this one. So that means we better go check the y-intercepts. They're different. That's good because that means they're parallel. If they were the same, then they would be the same line. They would be coincident. They're not the same line though because they have the same slope, but they don't have the same y-intercept. So B and C are going to be parallel to each other, we got to say. But then lastly, this is also the opposite reciprocal of this. So A and C are perpendicular to each other. So that means we would have to give 3 answers for this one because there's 2 pairs of lines that are perpendicular and 1 pair that's parallel. Okay? Questions on that at all? Don't pack up yet. We're not done. Look at the board over there. 12:50 is when class is over. We're going to do PEMDAS review real quick. What does PEMDAS tell us to do first, guys? Okay, that means what's in the parentheses. Don't try to distribute. That's multiplication. We got to do what's in the parentheses first. 3 minus 10, negative 7. What comes next in PEMDAS? Exponents. So we only do that. We don't touch 4 or 5. What do we get for negative 7 squared? Will it be negative 49 or positive 49? Because I always get a mixture of those two answers. Should be positive because negative 7 times negative 7 is 49. Then we do our multiplication. And then finally we can add.